Hey everyone, and welcome to our Trig application word problems. And this is a pretty good kind of summation of the skills that I wanted folks to have when they leave this unit is knowing what trig to use when in certain real world contexts. Obviously in this unit we also have some Pythagorean theorem and some special right triangles, but this is definitely the big takeaways in regards to trig. So with word problems, generally I would advise on this kind of following approach, which is to draw out the situation or diagram that is being um, asked of you, create an equation, solve said equation, and then when we get an answer, the difference mostly in word problems is that we're also going to take that answer and put it back into the context of the problem. So we won't just say, x is 10. We'll have to kind of say like, oh, that's going to relate to 10 feet or something along those lines. So for our first problem, and we'll do like the first page of this together just to kind of get a feel for it and see what's being asked of you, as well as talk about angle of elevation and angle of depression, which we may not have heard before, and then we'll see what we can complete independently after that. So OSHA, or the Occupational Safety and Health Administration, has regulations that state that ramp walkways be angled at no more than 20 degrees. So essentially, if we had a wheelchair ramp or anything coming into a building, it's not angled more than 20 degrees because it's just unsafe. So the question is, if we have a 20-foot ramp, then what is the maximum height that we can achieve? So in my diagram, I would say, okay, I have a 20-foot ramp. I know that this angle, in order to get the maximum height, I'm going to give this the maximum angle that I could possibly get, and that's 20 degrees, and then say, okay, what is this height, or, what can I clear if I needed to, potentially trying to get to like maybe a landing or something along those lines. So, okay, this is just a trig problem where I'm looking for the opposite, and I have the hypotenuse, so I can say that the sine of 20 degrees is equal to y over 20. I can multiply both sides by 20 to get 20 times the sine of 20 degrees equals y. And that is going to imply that y, let's see, 20 times the sine of 20, plugging it into my calculator. So I get from that y equals 6.84. So, we can go with shorthand, transition back to our answers. So I'm just going to say maximum height is 6.84 feet. So if I had a ramp that was 20 feet long, according to OSHA regulations, the highest that I could probably get to with that ramp is 6.84 feet. If you must reach a height of 6 feet, what is the shortest ramp that you can have? Okay, so I've got now similar drawing. I don't know how long my ramp is, and that's kind of what I was looking for. So this is now going to be, maybe we'll call this X. That's our unknown. I know that this is 20 degrees, and I'm trying to reach a height of 6 feet. This is again a case where I would want the largest angle allowable for 20 degrees. That's going to change our equation slightly. So now I have sine of 20 equals 6 over x. This is our special case where I can switch these two. So x equals 6 divided by the sine of 20. Plugging that into my calculator, I end up finding out that x equals 17.542. So shortest ramp is 17.542 feet to attain a height of 6 feet. So if a ramp has a horizontal distance of 8 feet and needs to reach a height of 3 feet, is it up to code? So this might be like if we have a space limitation and I'm trying to get something that is, to a height of 3 feet, maybe to the top of a set of stairs, like a little landing, and then I've only got 8 feet worth of horizontal distance to get there. Is that going to be up to code? Or, find that angle and then try to figure out if it's less than or equal to 20 degrees. So looking at what I know the opposite and I know the adjacent. So I'm going to state that the tangent of some unknown is 3 over 8. And in order to solve this equation, I need to take the inverse tangent of both sides. So when I take the inverse tangent of theta, I just get theta. And then on my right-hand side, I have this inverse tangent of 3 over 8. Heading to my calculator where I can do second tangent, 3 divided by 8. And then I'm figuring out here that theta equals 20.556. So this is not up to code. And I'm just going to say as theta is greater than 20 degrees. There are probably those kind of sticklers, just to kind of say like, hey, as soon as it's over 20 degrees, then that's not going to be any good. All right, so let's kind of take a look at the second situation. So Mark is flying a kite. Here we go. We've got Mark flying a kite. The angle of the string with the ground is 42 degrees. So here we've got this situation. Angle of the string, so this is 42.5, and we have 300 feet of string. So there's this. This is going to be where our kite is. Okay. How high is Mark's kite above the ground? So we are looking for this piece of information. Appears very similar to our first problem, so I might not even go all the way through in solving, just to save some time, but we can say the sine of 42.5 is y over 300. And then we would solve from there. Multiply both sides by 300 and report your answer out. This is going to be a good question because it highlights what an angle of elevation and angle of depression are, which I think we had talked about in both classes, but it's good to just kind of be aware of it anyway. So we are at the top of a 100-meter vertical cliff. A ship is spotted at an angle of depression of 12 degrees. So here I've got this. Here is my ship. And it's important to note here that, again, angle of depression or angle of elevation is in regards to the horizon. So we would generally consider this to basically be 0 degrees. And then this angle here is where our 12 degrees is. And that's not super helpful for our triangle. You can draw this triangle in different ways, but this is generally how I would envision it. But it's good to go and get this angle measure here. That is kind of our most useful, I would say. So that is 78 degrees. And I have 2 questions to kind of answer. How far is the ship from the base of the cliff? So that is this. And also find the distance from the top of the cliff to the ship. So that would also be here. 2 different equations to solve. So according to this angle, I'm just going to try to find x for right now. So this is opposite. This is my opposite side. This is my hypotenuse. This is adjacent. So I'm going to use tangent first. I'm going to say that the tangent of 78 degrees equals x over 100. And while I'm at this same stage, I'll probably use or come up with the other equation as well. So that looks like adjacent and hypotenuse. So I can say that the cosine of 78 degrees equals 100 over y. So these are our 2 different solving strategies. The one on the left, I'm going to multiply by 100 on both sides in order to get this. And then in the one on the right where my variable is in the denominator, I'm going to do this switch. So I'm going to plug these into my calculator. 100 times tangent of 78. Here I've figured out that x is 470.46, and then I have 100 divided by the cosine of 78, and I'm getting 480.97. So this x value was the distance from the base, so ship is 470.46. Looks like we are talking about meters from the base of the cliff. And then versus this value, which was our y value or our hypotenuse. So the ship is 480.97 meters from top of the cliff. All right, so there is probably going to be some translating work for the rest of these in terms of, hey, here's a problem situation. What is that diagram going to look like? And that is, for the most part, the struggle that I want us to have today. I don't think there's too much struggle with the trig, but some of that problem solving skills are definitely going to get tested. So yeah, complete those to the best of your ability, and we can go over them in class when we come back. All right, thanks everyone.